have the transformation y equals to 1 by z, and using that we have to transform this differential equation involving y and x into one with z and x. So we have y and z. So as we have dy by dx in this equation and not in this, we'd like to differentiate this equation with respect to x. We'll get dy by dx on this side, and we'll get minus 1 by z square times dz by dx on this side. Now we have this equation over here. Let me just write that. Yeah. So now we'll put dy by dx and plug in this value involving 1 by z square times dz by dx over here. And we'll put y equals to 1 by z, as there is no y in the following equation that we need. So we're just getting rid of all the y's. In this equation, see, we have x square dz by dx without anything in front of it. So if we don't want anything in front of dz by dx, we need to divide both sides with x square times minus 1 by z square. So we divide both sides with this. We'll get dz by dx minus z by x into 1 by z divided by x square into 1 by z square. We get z by x, and on the right hand side we'll get minus 2 by x square. So that's it for part A. For part B, you need to recall this formula where dy by dx plus py equals to q, where p and q are functions of x. In this case, the integrating factor would be e to the power p dx. In this case, instead of y, we have z. So the function of x, or the integrating factor, would be e to the power 1 by x, e to the power integration of minus 1 by x dx. So we get e to the power minus ln x. So this is basically e to the power ln x to the power minus 1. So the integrating factor is x to the power minus 1. Now to use it, on the left side we write d by dx times this variable, this, times the integrating factor, and we write this equal to the right hand side expression, this, multiplied by the integrating factor. So in this case it would be minus 2 by x cube. And now we can take z into x to the power minus 1 on this side and integrate the right side. We get z into x to the power minus 1 equal to 1 by x square plus c. And then we can just move this x to the power minus 1 to the right, and we just get 1 by x plus cx. The solution we found in part B, this, is basically a general solution, and this is with respect to z in terms of x. In part C, we want a particular solution. A particular solution is when a given value of y is given for a value of x, and we need this in the form of y equals to f of x. So we just plug in the value of z in terms of y, which is 1 by y. Now we know, now we can take a y to be the subject. Now we'll get 1 by x plus cx, and now the values of x and y are 3 and minus 3 by 8. So we just put in the values and get this. Now we need to make c the subject, so we can just bring this minus 3 by 8 down and take 1 by 3 plus 3c over here. So we'll get my 1 by minus 3 by 8. Now we can take c to be the subject. This will be 1 by minus 3 by 8 minus 1 by 3 and divided whole by 3. And if you calculate it, it will be minus 1. So we'll just put in c equals to minus 1 here, and we'll get the function we need. So y is 1 by x minus x. That's it for question 3.